part one of two parts in terms of this review. So I'm going to go over the first 13 questions in this video. All right, so the first question says, what is the total area of the regions between the curves y equals 6x squared minus 18x and y equals negative 6x between 1 and 3? So I'm going to go to Desmos to graph this. All right, so I'm going to graph 6x squared. I already messed that up. 6x squared minus 18x. Okay, and then negative 6x. It says from 1 to 3. All right, so if I come back over here and look at it, all right, so we have, here's 1 to 3. All right, and if you look, let me actually get one of these to go from 1 to 3. I think it'll be easier to see. Okay, if you look, we have from 0 to 1, all right, or excuse me, from 1 to 2, I should say, from 1 to 2, the green line, so my linear function, is above my quadratic piece. And then from 2 to 3, my quadratic piece is above my line, my linear function. So I'm going to set this up and break it down into two different integrals. The first one is going to be from 1 to 2, where the line is on top. And then the second one from 2 to 3 is where the quadratic is on top. I'm going to add them together. All right, so for number 1, I'm going to write down the integral from 1 to 2, where the line is on top, so negative 6x minus 6x squared minus 18x. Right, and then do the same thing, but for 2 to 3, where the quadratic piece is on top. Okay, so that's the setup. Now from here to the rest of the problem, it's just going to be basically some algebra, then some calculus on how to do this. All right, so I have the integral from 1 to 2, and I have negative 6x squared, and then negative 6x minus a negative 18x is actually going to be plus 18x. That's going to be plus 12x. Okay, and then the integral from 2 to 3 is going to be positive 6x squared, and negative 18x plus 6x will be minus 12x. All right, so take your time to do these separately. So my antiderivative is going to be x cubed. And I need it, when I multiply by that 3, it needs to be negative 6. So that's going to be negative 2x cubed. And then for this, it'll be x squared. And a 2 times some number to give me 12, so that'll be 6. So evaluate this at 2 and 1. And then this antiderivative is going to be 2x cubed minus 6x squared. And that one's evaluated at 3 and 2. All right? So I have negative 2 times 2 cubed plus 6 times 2 squared minus negative 2 times 1 cubed plus 6 times 1 squared. Okay, all of that plus 2 times 3 cubed minus 6 times 3 squared minus 2 times 2 cubed minus 6 times 2 squared. All right, so that's a lot going on. All right, but ultimately, it's not so bad because you don't have any fractions, at least, so that's nice. All right, so this is going to be 2 cubed is 8, so that's negative 16. 2 squared is 4. 4 times 6 is 24, so negative 16 plus 24 is 8. And it's going to be minus 1 cubed is 1, so that's a negative 2, and that's going to be 6. So negative 2 plus 6 is 4. And then this one is going to be, let's see, that's 8 times 2 is 16. Again, if you want to put this into Desmos, feel free to. So that's 16, and then that's going to be 9 times 6 is 54. So 16 minus 54 is negative 48. That's not right. Negative 38. and then minus, let's see, that's going to be 8 times 2 is 16, and 2 times 2 is 4, 4 times 6 is 24, 16 minus 24 is a negative 8, so that comes plus 8. Let's see if I get this right. So that's going to be 4 plus negative 38. So that's going to be something I did wrong. Hold on one second. Let me find my mistake. Okay, so I found what I did wrong. 3 cubed is 27. My mistake was right over here. 3 cubed is 27 times 2 is going to be 54. 3 squared is 9. 9 times 6 is 54. So that's actually going to be 0 minus a negative 8, which becomes 0 plus 8. So 4 plus 8 is 12. So again, I apologize for that. Number 2. All right, so number 2 says the area of the shaded region in the figure above is represented by which of the following integrals? So it looks like we're going from A to C, all right, and f of x is above g of x the entire time. So I'm looking for the integral from A to C where it says f of x minus g of x, which is going to be d. Number 3, find the area of the region between the graphs of x squared and negative x from 0 to 2. All right, so I'm going to type all this into Desmos and get an idea of what this looks like. All right, so I have x squared, and then I have negative x, and x equals 0 and 2. Okay? So it looks like from 0 to 2, right, from 0 to 2, I have the green function is above the purple function, so my line, the entire time. So in terms of figuring out what the area is between these two curves, I'm going to subtract my quadratic minus my linear function. All right, so the integral is going to be from 0 to 2 of x squared minus negative x. Okay, so I'm going to kind of write that a little bit nicer. So that's x squared plus x. And I can do the antiderivative of each of these. So you get 1/3 x cubed plus 1/2 x squared, evaluated at 2 and 0. So I'm not actually going to evaluate this at 0 because that's just going to be 0. So it's 1/3 times 2 cubed plus 1/2 times 2 squared. That's going to be 8/3 plus half of 4, which is 2. Getting a common denominator for 2 would give you 6/3. So 8/3 plus 6/3 would give me 14/3. All right, so that's number 3. Number 4 says the area of the region in the first quadrant that's enclosed by these two graphs, a cubic function and a linear function. All right, so let me go to my graphing calculator to graph x cubed plus 8. And then I'm also going to graph, sorry about that. I'm also going to graph x plus 8. Okay. And if you look, let me make this a little bit nicer to see. So 0, 1, 2, 3, 4. Right, if you look here, well, that made it worse. Let me zoom in. Let me try this. There we go. That's a little bit better. Okay. So if you look at the area where it's bounded in the first quadrant, it's actually just this tiny little piece here. All right. From x is 0 to x is 1. All right. Because if I go past that, you'll notice that the curve is going to keep going up and the line is going to stay obviously with the same slope. So that area is going to be infinite. It's going on forever. So really, this is the only one that I can actually find a definite integral of for that area between the two curves. And you'll notice my line is actually above my cubic function. So I'm going to subtract my line minus my cubic function on the integral from 0 to 1. So the integral is going to be from 0 to 1 of my line, so x plus 8 minus my cubic function, so x cubed plus 8. All right, so integral from 0 to 1. That means I'm going to have a negative x cubed, a positive x, and 8 minus 8 is actually 0. All right, so let's find the antiderivative. So negative 1/4 x to the 4th power plus 1/2 x squared, evaluated at 1 and 0. So negative 1/4 times 1 to the 4th power plus 1/2 times 1 squared. I don't need to plug in 0 because that's just going to be 0. So that's negative 1/4 plus positive 1/2. So that's going to be negative 1/4 plus 2/4, which is a positive 1/4 for the area. So 4 is A. All right, let's go to number 5. All right, another one of these where it's asking you to just pick what would represent this. And it says, which of the following represents the area of the shaded region in the figure above? All right, and if I look at this, there's kind of two ways to look at it. You look at it in terms of the x-axis to the y-axis, but the reason I can't choose the x-axis or the y-axis because I have that gap in between there. So if the A was on the y-axis, it could be a couple answers here, but it's not. So the integral is going to be from A to B, where your line, right, that line, y equals d, is on top of the function the entire time. So it's going to be d minus my function. So I'm looking at letter B for this to make sense, where it's the line minus my function. You're going to see another problem that we do later, where it's actually this exact piece. All right, so 5 is B. Let's do number 6. I'm going to graph this natural exponential function, e to the power of 2x, the x-axis, the y-axis, and the line x equals 2. All right, so e to the power of 2x, and I also have the x-axis, so x equals 0, the y-axis, so sorry, the y-axis is x equals 0, the x-axis is y equals 0, I apologize, and then x equals 2. Let's see what's happening here. Okay, and if you look, right, see where they actually intersect, way up here. There it is, at 2, right? So these curves, or I should say the curve of e to the power of 2x intersects x equals 2, obviously at 2. So when I'm trying to find the area under the curve is from 0 to 2, right? So 0 to 2 of e to the power of 2x, okay? So the integral from 0 to 2 come on, come back to me. There we go. So the integral from 0 to 2 of e to the power of 2x dx. So I'm going to do the antiderivative of e to the power of 2x. So I start with e to the 2x, and if you remember from when you take the derivative of this, you have to take the derivative of what's in the exponent, which would be 2. So to keep that being a 1, I'm going to put a 1/2 in front. Evaluate this at 2 and 0. So it's 1/2 times e to the 4th power, right? 2 squared is 4, minus 1/2 times e to the 0 power, right? So that's e to the 4th power over 2, and then minus, and e to the 0 power is 1, so that's 1/2. So I'm looking for this to be my area, which is C. Let's go to 7. All right, so it tells us that we have this figure showing y equals 5x minus x squared, and the graph for the line y equals 2x. What is the area of the shaded region? So I'm going to graph this quadratic and this linear function to help me get my limits of integration. So 5x minus x squared. So 5x minus x squared. And the other one is 2x. You can see that we're starting at 0, and they intersect at 3, 6. So in terms of my x values, my limits of integration are going to be 0 to 3. All right, now when you look at it, you can look at this figure here, or you can look at what you graphed. The blue curve is always on top the entire time from 0 to 3. So I'm going to do the quadratic minus the linear piece. So 5x minus x squared minus 2x times dx. Okay, so it's going to be the integral from 0 to 3 of negative x squared, and 5x minus 2x is 3x. And we're ready to find the antiderivative. So negative 1/3 x cubed. All right, this needs to be x squared, but I need 3 in front, so I'm going to put 3/2. Evaluated at 3 and 0. Again, I don't need to do 0, so I'm just doing 3. Negative 1/3 times 3 cubed plus 3/2 times 3 squared. So that's negative. So 3 times 3 is 9. 3 cubed is 27. 27 divided by 3 is 9. There we go. Plus that's going to be 27. 9 times 3 is 27/2. So negative 18/2 plus 27/2 is 9/2. So B. All right, so number, wait for it, 7 is B. Number 8. Another one where I'm trying to find the area bounded by some lines and a curve. All right, so I'm going to plot y equals e to the power of x. And then I have x minus 1. And then I have x equals 1 and x equals 3. Okay, so if I look from 1 to 3, so from 1 to 3, it looks like the purple curve, e to the power of x, is going to be, above my line, my linear function, the entire time. So I'm going to do e to the power of x minus my linear function of x minus 1. So the integral for 1 to 3 of e to the power of x minus x minus 1. Okay, so that's the integral from 1 to 3 of e to the power of x minus x plus 1. Let's find the antiderivative of this. So the integral of e to the x is actually just e to the x minus 1/2 x squared plus x, evaluated at 3 and 1. All right, so I have e cubed minus, that's going to be 3 squared is 9, so 9/2 plus 3 minus e to the first power minus 1/2 plus 1. That's e cubed minus e. So negative 9/2 minus a negative 1/2 is actually plus 1/2. So that's going to be negative 8/2, which is negative 4. Negative 4 plus 3 is negative 1. Negative 1 minus 1 is going to be minus 2. So this ends up being my answer, which is B. Almost there, guys. Remember, going to 13, then I'll be done. Number 9. All right, so we have R is the region that is bounded in the first quadrant by the graph 7/3 x plus 1, and below by the graph of y equals 2 to the power of x for 0 to 3. So let me go to Adesma so we can see how this looks. So 7/3 x plus 1. And 2 to the power of x. Okay, so if you look, right, we have the integral from 0 to 3, and my line is always bigger than my exponential on that integral. So this one, my line, so number 1 is going to be right. But the reason it's not only that one is you have to check to see if it could be a different one. So if you notice, the option 2 and 3 are talking about y's. So what I'm going to do is I'm going to rewrite each of these in terms of solving for x by itself. So y equals 7/3 x plus 1. I'm going to solve for x. So y minus 1 equals 7/3 x. So to get the 7/3 to go away, I'm going to multiply both of these by 3/7. Same idea for this. Y equals 2 to the power of x. All right. Hopefully you remember from your days in pre-cal that we need to get rid of that x out of the variable by taking the natural log of both sides. That's going to move the x in front. And then it's going to be the natural log of y over the natural log of 2 equals x. All right? And the way that I know which one to pick is by the limits of integration, right? If you look at 2 and 3, you'll notice their limits of integration are different. All right, so if I look, that's about the y's. So when I look at my graph, I should be looking at the y values, which is 1 to 8. So you look here, and number 3 is going to be the other one. So it's going to be D. So number 9 is D. All right, 4 more to go. Number 10, all right, we have the area of the region in the first quadrant bounded on the left by the graph of x equals y squared over 2, and on the right by the graph of this function. It's a line between 2 and 4. Now, you actually could do this right away, right? The integral of 2 to 4, it's the one on the right minus the one on the left. So it would be 3y minus 4 minus y squared over 2 dy. Okay, but if you want, I can graph it for you so you can see that. So x equals y squared over 2. Okay, and then we have x equals 3y minus 4. All right, so if we're looking at the area bounded here, let's see if I can get it for you. There we go, boom. All right, you can see we're going from our y values of 2 to 4, okay? And again, in this case, we have, we're looking at the one on the right as opposed to the one on the left, okay? Okay, so now I'm ready to kind of clean this up just a little bit. You don't have to put it in this order. I just like to put it usually in my standard form kind of thing. So negative 1/2 y squared plus 3y minus 4. All right, so let's find the antiderivative. So I know I need y cubed. And when I multiply that by whatever my coefficient is going to be, my constant there, it needs to become negative 1/2. So it's actually, I needed this to be negative 1/6, right? Because 3 times 1/6 is 3/6. All right, so plus this is going to be y squared, and I need that to be a 3, so I need 3/2 in front there. And then this is going to be minus 4y. All right, evaluating this at 4 and 2. So I have negative 1/6 times 4 cubed plus 3/2 times 4 squared minus 4 times 4. Whatever that is, minus the same thing, but for plugging in 2. Now, you will have decimals available to you if you want to type all this in, and then you'll compare it to what you get for your answers. All right, I'm going to show you how to kind of do this without doing it. So that's going to be negative 64/6. This is going to be, let's see, 24, then minus 16. This is going to be negative 8/6. And then that's going to be plus 6, and then minus 8. So if I do all the numbers that are not fractions, I have 8 minus a negative 2, which is actually 10. Then negative 64/6 plus 8/6, right? Subtracting negatives addition is going to be negative 56/6. So it's going to be letter A. All right, 3 more. Number 11. All right, so we're looking for the area in the first quadrant bounded by this y equals 2 to the power of x, the horizontal line and the y-axis. So interesting thing here, we're going to actually be looking at and making an integral with y, okay, with respect to y, or dy. So I have 2 to the power of x, and I have a horizontal line y equals 4, and the y-axis, which is x equals 0. Okay, so I zoom in here. We're going from the y values of 1 to 4, and we're looking at this function, which is 2 to the power of x. Now, I'm going to be doing an integral with respect to y, so that means, this is what I mentioned in our lesson, that we need to go ahead and actually rewrite y equals 2 to the power of x as a function in terms of y. So I'm going to take the natural log of both sides, so I can get that x out of there. That's the natural log of y equals x times the natural log of 2. I'm going to move that over with division. So the natural log of y over the natural log of 2 equals x. So my integral, I think my y values were 1 to 4. Yes, so of 1 to 4 of the natural log of y over the natural log of 2 dy. All right, now the natural log of 2 is actually just a constant, but it's in the denominator. So when I pull that out, I'm going to put 1 over the natural log of 2 times the natural log of y dy. All right, and if you look at your formula sheet, the integral of the natural log of whatever your variable is, your argument, is going to be that variable times the natural log of that variable minus that variable. So it's y times the natural log of y minus y. So y times the natural log of y minus y, evaluated at 4 and 1. Now don't forget, I will multiply all that by 1 over the natural log of 2 once all said and done. So I have 4 times the natural log of 4 minus 4 minus 1 times the natural log of 1 minus 1. All right? So that's going to be 4 times the natural log of 4 minus 4. The natural log of 1 is 0. So that's 0 minus 1 is negative 1, but subtracting that, you get plus 1. So 4 times the natural log of 4 minus 3. I do need to multiply each of those by that 1 over the natural log of 2. So that's 4 times the natural log of 4 over the natural log of 2, and then minus 3 over the natural log of 2. Okay, I'm going to go to Desmos to show you that the natural log of 4 over the natural log of 2 is going to actually simplify for us. So we have 4 and times the natural log of 4 in the numerator, and the natural log of 2 in the denominator gives us 8. That's going to become 8 minus 3 times the natural log of 2. So that is answer choice A. All right, 2 more to go. Now, number 12 is saying to find which of these answer choices would give you the sum of the area of the shaded region. So it looks like there's kind of 3 of them. So my first thought is I'm looking for 3, and only 2 of them have 3. We'll talk more in class or other times that you can have one if we're talking about the absolute value, but none of these answer choices include the absolute value. So it must be one with 3 of them. So I've got 0 to pi over 6, pi over 6 to 5 pi over 6, and then 5 pi over 6 to pi. Those are all the same for B and C. But if you notice the first one, the one that y equals 1 is actually on top. So that's going to be 1 minus, right? So that looks good. Then for the middle piece, it's the sine function that's on top. Then the last piece, it's back to the 1 being on top. So C looks like the one that makes the most sense. Okay, last one. Okay, so kind of similar to the one you just looked at, we need to break this up into 2 integrals where the line is on top first, and then the second integral where it's on the bottom. Okay, so what I'm going to do is I'm going to graph 7x minus x squared. So 7x minus x squared, and then I think it's y equals 10, confirm. Yes, and we're looking between 0 and 5. Okay, so there we go. So if you notice from 0 to 2, right, the line is on top, which is in that same figure you're looking at on your paper. And then from 2 to 5, the curve, the quadratic, is actually on top. So from 0 to 2, I'm going to be writing 10 minus the quadratic. And then from 2 to 5, it's going to be the other way around, the quadratic minus 10. So from 0 to 2, it's 10 minus the quadratic of 7x minus x squared, all of that dx, plus the integral from 2 to 5 of the quadratic. There we go. Minus the line dx. Okay? So take your time on this. It's going to be, it's going to take a little while to get all this. I like to put it in standard form first. That's just my preference. So it's x squared, and then minus 7x plus 10 plus the integral from 2 to 5 of negative x squared plus 7x minus 10. Okay, so my first one, I only need to plug in for 2, right? Because if I do the integral, the antiderivative, you'll see I won't need to use 0. So this is 1/3 x cubed minus, so we have 7/2 x squared plus 10x evaluated at 2 and 0, but really just 2, plus we have negative 1/3 x cubed plus 7/2 x squared minus 10x evaluated at 5 and 2. All right. So at this point, if you want to go to Desmos to type it all in, that's fine. I'm going to probably end up doing that anyway. But I'll show you all the plugging in steps. So 1/3 times 2 cubed minus 7/2 times 2 squared plus 10 times 2. So that's just going to, I always think of that as like one piece because I don't have to plug in 0. Plus, so here's my next one, negative 1/3 times 5 cubed plus 7/2 times 5 squared minus 10 times 5. All of that minus negative 1/3 times 2 cubed plus 7/2 times 2 squared minus 10 times 2. Okay, that's kind of like my second piece, okay? So now, the last part of this is I'm going to go to Desmos and try to get what my answer is. And then once I have my answer in a fraction or in a decimal, whatever you want, I'm going to go through the answer choices and see which one matches, okay? So I'm going to do 1/3. All right, so I have 1/3 times 2 cubed gets minus, let me check, minus 7/2 2 squared, and then plus 10 times 2, confirm. Yes, okay, so that's my first piece. I'm going to duplicate this, right, because you see I just need to change the signs a little bit. So if I duplicate it and change this sign to negative, this to a positive, and this to a negative, and then plug in 5, and then do the same thing, duplicate that, but this time plug in 2. Have my 3 things add together, or I guess I should say. First, subtract these. So I have negative 25/6 minus negative 26/3. That gives me 9/2. And then the last thing is to add together my 26/3. The very first thing I did, 26/3 plus 9/2. 26/3 plus 9/2. So my answer is 13.16 repeating, or 79/6. So that's my answer, 79/6 when you all said and done. All right, so all of this, let me give you a little more context. All of that was 26/3. So this is 26/3 plus, and then all of this we said was 9/2, I believe. Yes, 9/2. All right, so all that was 9/2. And then when you get that finished, it becomes 79/6. So this is my answer that I'm looking for. And if you were to type in A, B, C, and D, the only one that gives you 79/6 or 13.16 repeating is going to be letter C, as in cat. All right, guys, that's it for part 1. Pick it up with part 2 to get ready for this test.